Folks, welcome back for another award-winning video. This time we're talking about other algebraic functions. And other algebraic functions is a catchphrase for stuff that doesn't fit into the other buckets of material that we have for this course. So we're going to look at a lot of different random things today. It's basically a potluck, if you will, of algebra. Hopefully you find it enjoyable and satisfying. All right. First, we're going to talk about some domains of things. For this lesson, I basically have, let's see, there's 10 different example problems for you with hints about things that often trip students up. Also, on the back side of the notes, I just have the laws of exponents, definition of the nth root and properties of the nth root, and definition of rational exponents. That stuff on the back is all review. It's just there as a reference for you should you forget some of those rules that I use throughout the solution of these problems. But let's start to talk about some domains. In question 1 here, we have f of x equals 3x divided by the cube root of x. And the hint is what types of things cause domain restrictions? Well, we have a 0 in the denominator causes a domain restriction, as well as a negative input to a root that is even. Well, we have a cube root here that's not even, so it's okay to put negative numbers in for x. For example, the cube root of -1 is just -1. The cube root of -8 is -2. If you don't believe me, test it out on your calculator. So this function here only has a domain restriction when x equals 0. So our domain here is just x cannot equal 0, because then we would have a division by 0 error. All right, let's move on. Example 2, we have the quantity 4x squared divided by the cube root of x minus 7. Again, cube roots of negative numbers are okay, so it's okay to have the cube root of -1 or -5 or -7, but it's still not okay to have a 0 in the denominator. So this function cannot have x equal to 7. That is a domain restriction because that would give me a division by 0 error. Things get a little more interesting here in example number 3. We have the the fourth root of x plus 3. All right, so fourth root, I'm just going to highlight that for you here. That's an even number. And then out here I have the second root of a quantity. So we do have to be careful about negatives. So let's first look at the fourth root. For that fourth root, x plus 3 has to be greater than or equal to 0. That gives me x has to be greater than or equal to -3. Okay, so we got that, and now the next thing we have to do is look at the square root. So I have 2 minus this quantity, the fourth root of x plus 3. Well, let's see, the fourth root of x plus 3, that I have to make sure that thing doesn't cause this root to be negative. So what does that mean? Let's take a look at that. So the fourth root of x plus 3, that needs to be less than 2. So let's go ahead and write that out. The fourth root of x plus 3 has to be less than or equal to 2. Because if it's not, then I would have a negative number under that green square root symbol. Okay, so if I raise both sides of this to the fourth power, it gives me something like this. X plus 3 has to be less than or equal to 2 to the fourth. Let's see, we go 2, 4, 8, 6. That's going to be 16. So that means x has to be less than or equal to 13. So what is my domain? I have one restriction up here, and then I have another restriction down here. When I combine those two, I get the following domain. So we have a left-hand boundary of -3 and a right-hand boundary of 13. So as long as x falls in that domain there, in that interval, then we'll have an output for the function h. All right, folks, so we're done with these questions about domain. Let's move actually into some solving stuff. So question 4 through 10 says solve the following equations and inequalities with a little hint on each side. So let's go ahead and I've got a separate page set up for each of these just to give us a little bit of room to work. All right, first thing we have here is x minus 3 is equal to the quantity, the square root of the quantity 6x plus 9. And this little note here says, don't forget to check for extraneous solutions. First thing I notice is I have that square root symbol, so I better make sure that 6x plus 9 is greater than or equal to 0. That means 6x has got to be greater than or equal to negative 9. That means x has to be greater than or equal to negative 9 divided by 6, which is negative 3/2. That reduces to negative 3/2. So just going to make a mental note about that and check back at the end to see if that comes into play. So back to the equation. How on earth do we solve something like this? Well, one thing that we've been taught since an early age is we can get rid of this square root symbol by squaring. Boy, I wish Smart Notebook would let me do that. We can get rid of that square root symbol by squaring both sides of this equation. So I'm going to go ahead and give that a shot. We're going to do x minus 3, that quantity squared, equals the square root of 6x plus 9, that quantity squared. So left-hand side, we're going to go ahead and expand this. That's going to be x squared minus 6x plus 9er, and that's going to be equal to 6x plus 9er on the right-hand side. Because when we square something that was under a square root symbol, we basically get that value returned. All right, so let's see what happens here. I've got I'm going to subtract 9 from both sides. Those values disappear. And I'm going to subtract 6x from both sides. I'd like to get a 0 on one side because then I can try to use the zero product property. So that's going to give me x squared minus 12x equals 0. I'm going to factor my left-hand side to x times quantity x minus 12. That's great. We now have a product on the left-hand side of our equation. That's good because the zero product property tells me that x is going to equal 0 or x equals 12, and that's great. So we can move on. However, don't forget, there's a note up here that says don't forget to check for extraneous solutions. In fact, I had this note here that said x has to be greater than or equal to negative 3/2. Okay, folks, let's we're wrapped up 4 here. Let's move on to 5 and try to squeeze one more video into this, one more question into this video before we start to break things up. Okay, so how does this function behave with negative inputs? Well, I have x as my input, and then I'm raising it to the 2/3 power. Remember, this is a rational exponent, so each of these pieces does something different. So the 2 in the numerator there, that's a squaring. Okay, so that we're squaring the input. The 3 in the denominator means we're taking the cube root. Okay, so we're taking the cube root. So my solution strategy here, I have to be careful. I'm going to start with, x to the 2/3 equals 9. And then first thing I'm going to do is get rid of that 3 in the denominator, get of that exponent. The way I do that is by cubing. Okay, so I cube both sides. 2/3 times 3 is 2. So the left-hand side of this becomes x squared. And then I have 9 cubed, which is actually 729. Okay, so there's a reason why I got rid of the 3 in the denominator first. I know that I can take a cube root of a negative number, and I know that I can cube a number, and it preserves the sign. So whatever the sign of the input was, it will stay the same based on what I just did. Now comes the tricky part, and this one trips students up all the time. So we have x squared equals 729. What I want to do is extract a square root, and everybody knows that. I mean, that's something you learned back in, like, I don't know, pre-algebra days, or even maybe before that. Maybe they're teaching that in kindergarten now. I have no idea. But the square root of x squared is fine on the left-hand side. That gives me x. But the right-hand side is where we have a problem. The right-hand side is, I added a square root symbol to the problem, so I have to consider both the positive and negative square root of 729. If you check this one on your calculator, I'm pretty sure that you are going to get an answer of 27. But don't forget, it's plus or minus 27. And if you don't believe me, double check the graph of x to the 2/3. This is one of my favorite graphs, folks. If you take a look at this thing, it has a very pleasing shape to it. It kind of comes in and it does this, and then it takes off again. Looks like a seagull, doesn't it? A little fun fact for you. This little feature, we call that a cusp. We'll learn more about that next year in AP Calculus. All right, folks, that's enough for this video. We're going to shut it down and then fire up a new one for the rest of these problems.